each droplet expands 1,700%. So a micro droplet is expanding out, absorbing all the heat that's in that fire, and turns to vapor. So there is no steam to harm the firemen. There's no water runoff because the water has done its job. It absorbed the heat and went away. So a stream that is coming in a fan is now 1,700% larger, absorbing all of the BTUs that's within this now 1,700 increased range. It's much more efficient because now you have, instead of just a fog coming out of a normal fire nozzle, it's now much broader, but most importantly, you have fine little water droplets. Each water droplet is absorbing heat. In a normal fire hose, you have a stream of water coming out. The outside of that stream, yes, it is absorbing heat, but the middle of that stream is doing nothing more than going out the other side of the car. So here we're using all the water. We're using the efficiency of the water that's inherent characteristic of the water itself. That's why there's no runoff. It's vaporized. It's done its job. It takes the BTUs and reduces them. There's a study that shows in a house fire, the temperature at the ceiling was 1,600 degrees. FireXpress came in with their nozzle and it instantly went from 1,600 to 400. Now at 400 degrees, very few things burn. Paper burns at 450 degrees. So if it's 400 degrees, paper's not burning. So you've taken all the combustible gases and reduced them down to something that's manageable. When you're pushing out 1,700%, all that air that's fuel to the fire is now displaced. So now the fuel, in the fuel triangle, there's no oxygen and there's no combustible gases to keep the fire going. So you've destroyed two sides of the fire triangle right there.